Hello, and welcome back to another episode in recreating Baldur's Gate 3's camera system inside Unreal Engine. In the last episode, we made a start on the material function that allows us to mask the environment and see the character at all times through it. And that is a good start. However, there's a few things we need to do to really bring this more to life. Now, the first thing is obviously the polish stage, which is adding that noise effect to the perimeter of the mask. And also, there's a few bugs that we need to fix up from the last time. As you can see, and I mentioned it last time, you can currently see through all the environment beyond the character. And that's obviously not something we want. We want to stop the mask at the character's distance. We don't want this infinite mask that we can see beyond the character through environment that, shouldn't really be visible. And yeah, the other thing that we're going to fix up is if I exit here, you'll also notice that none of these objects have their shadows working anymore. Now, it's a bit easier to see if I drag this out here, because there is a shadow from the landscape still being cast into this general area. But you'll notice that none of these actors have any sort of shadow. Now, I was confused what was going on with it. So I did a bit of research, and it looks like it's something to do with using the pixel depth in our material function. If I drag that over, because we're multiplying the pixel depth, it's apparently causing some issues with the opacity mask or the shadow depth pixel shader. Now, this is a bit out of my expertise, so I'm not exactly sure how this affects things, but we do have a solution to kind of step around this, and in a way that we want it to work anyway. So, the first thing I'm going to do is I'm actually going to solve that shadow issue, because it's very quick and very easy. The only thing that we need to do is we need to add a node to the material function. And this is called the shadow pass switch. And we're just going to plug this in right at the end of the material function. We're going to plug clamp into default, the output pin into the output result, and shadow, we're going to just use a value just like 1 or something. Again, holding down 1 while I left click to get that. And if I apply and save now, there we go. Shadows are back to functioning as they were. And another reason why this is a really good thing to just have anyway is because when you're working with masked materials, sometimes it can affect the shadow in other ways that are beyond this bug. Like if you have a masked object and you've got a masked portion of it, light will fall through and cast, or you'll have light where you probably want a shadow. This just ensures that a shadow will appear for the object, even if the object is being masked out. So this is good for areas that are in shadow that you want to stay in shadow. So yeah, that's basically that. The next thing we want to do is let's have a bit of fun. Let's add the noise next. So we're going to go back into the material function, and I'm actually going to work with the simulation in place. So I'm going to hold Alt-P to start playing. And I'm just going to get my character in a position that will be easy to view what I'm doing. So there we go. We can see the character. Now, to add noise, there's a few ways we could go about this. What I'm going to do is I'm going to use the noise node. Now, if you have a noise texture, that might be cheaper. I'm not exactly sure. I know this node can be a bit expensive. But we're going to do all we can to kind of reduce the cost of this node. So now that we've got the noise node, what we're going to do in the details panel for the node, we are going to adjust some values. So the scale, we're going to reduce this right down to like 0.0. Let's try 0.03, see how that works. And the function that we're going to use to generate the noise, we are going to use fast gradient. So it's a much quicker algorithm that's used to generate this. Levels, we're also going to reduce right down to 1. We only need 1 pass of it. And the output min and max, we're going to change the output min to 0 because we don't care about any values below 0. Output max is going to be 1. And what else? Turbulence. How multiple frequencies are getting combined. we might turn this off as well. Let's have a peek as to what this looks like. So what we're going to do with the noise is we're going to hold down 1 for a scalar parameter, and left click, of course, and just put 1 into filter width. And the position that we want to generate this noise around is going to be the pixel location. So I'm going to drag out from the XYZ of the absolute world position. And now that we've got this, let's start adding this into the function that we've already got set up. So what I'm going to do is I'm going to multiply everything before the clamp by this noise. And you'll see why in a second. So if I do multiply and hook this up and plug this into the clamp now, oops, and apply, it's going to take a quick second to generate. You'll notice that this looks a bit odd, but we'll see how that actually looks in the world once it compiles. Okay, so you can see it's already getting the effect that we want. Now, the kind of brainy squiggles we can disable with the turbulence tick box. So that affects how those, what does it say? How those frequencies are getting combined. If we turn that off and apply and save that, that should solve that issue there. You'll see it's a lot more, or a lot less brain-like. And if we take a look, there we go. It's already pretty much exactly what we need, but I'm going to add another step just to kind of polish it up a little bit further. What I'm going to do is after the multiply, we're actually going to add, get the add node, the previous value to the now multiplied value. And the reason why we're doing this in 2 steps using what we have previously is the multiply brings all those values to a 0 to 1 kind of scale, and then the add limits that to what's already being masked. We only want to affect the area that's already masked and not have like little specks in the environment around. So if we add and plug that in now, apply and save, and once this generates, you'll notice already it's like you can see that the noise is only affecting the outreaches now. So that's already a lot better. Now, we will clean this up because right now it's not really affecting as much as I would want it to. So there's a few values we're going to change here. We are going to, let's see, we're going to reduce the noise scale to, let's try 0.025. And let's up the occlusion size as well, so we're affecting a larger area. We'll double it to 80, apply and save. And now we'll let it compile once again. And there we go. Now it's already kind of coming together pretty nicely. You will see as well, it does go beyond the character, which we will be fixing up now. So we will now stop the mask once it's beyond the character. So if I hit play once again, this is what we're solving. We're solving the area that's beyond the character now. And I'm sure there's a better way to do this. If you know of a better way to do this, please leave it down in the comments because I'm not too happy with how I'm solving this. What we're going to do is we're going to compare the distance from the camera to the pixel being rendered from the camera to the player's location. And if the pixel is further than the character, then we're not going to affect it. We're just going to have a value of 1 for its opacity, meaning it is always being rendered. So how do we do that? What we're going to do is we are going to get the distance. If I find the, where is it? Utility distance. We're going to do this twice because we need 2 distances. One, of course, is the player location. We'll do this in the top node to the camera. And again, from the pixel location to the camera. Oh, whoops. Now that we've got that, we are going to compare these 2 values in an if statement. So plug that into A and B, and we are going to plug, we're actually going to get another scalar value and plug that into, hold on, what am I doing here? We are comparing A, which is the distance from the player to the camera, to B, which is the distance from the pixel location to the camera. I'm just going to swap those around because that makes more sense in my head. So we are comparing the distance of the pixel to the distance from the character. And if the pixel is further than the character, meaning A is more than B, we are going to want a value of 1, meaning always render it opaque. And we're actually going to plug this into A equals B as well. And if A is less than B, what we want to grab is the value that comes after the clamp. So everything we've done before is now only being affected if it's between the player and the character. And now we can plug this output node into the shadow pass. And let's see if that works. Apply, save, drag that off to the side, let the shaders compile. And there we go. Now, let's hit play and see how it looks. There you have it. It is no longer affecting anything beyond the character. It is only affecting what's between the character and the camera. So that's awesome. Now, let's see what else we can change in the noise to kind of clean that up a bit, because I think we want it a bit more pixelated than it currently is. So what we might try changing is the occlusion size again. Let's try, I'm not sure, let's try 120 for the occlusion size, and for the noise, let's change the scale down a bit to 0.01. Apply and save. We'll let it compile again. And hit play, of course. Bit of lag there. Okay, so we're actually getting less noise the smaller value we go, so let's do it the other way around. Let's up that to, the noise to 0.04. Once again, apply. Once again, wait for the shaders. It's the most annoying part of working with materials. All the waiting. But it's so worth it because you get really cool effects like this, and I'm definitely going to be diving more into it as I go along. And there we have already a much nicer and more accurate noise masking shader that we will be using throughout our environment. So awesome. We've solved our issues. We've got the mask working. Now what we want to do is, in the next episode, we're going to clean this up a bit. We're going to stop the camera going up when you collide with the environment. We are going to get a start on another type of masking, which is going to use dithering to mask out entire rooms, which is another kind of big part of the system. So I will see you there. And yeah, enjoy.